All right, part two, exponential functions. So now we're going to write equations or functions that use exponents, okay? So there's two parts you have to know for sure. A times b to the x. Now, the a, we call this the y-intercept. I know it's different from the other one. In the linear formula, the b was your y-intercept. Not here. That first number is your y-intercept. The b, we call it the common ratio. Okay, now I'm going to give you some non-math words for this, okay? So for the y-intercept, I like to call this the starting point or the start. And we usually start at 0, okay? So you're starting at the y-intercept. The common ratio, I like to call this the multiplier. Because there's a pattern to these things, we're looking for a multiplying pattern, not an adding pattern, okay? But this is basically the layout for all your formulas, okay? So let's look at this table. The first thing you want to identify is the y-intercept. So the y-intercept here is 5. So our a is going to be 5. Now, the next thing you want to identify is the pattern. What is the common ratio? What is your multiplier? So when you're looking at this, it's not going to be 5 because we're not adding by 5, and it's not 10. What is it multiplying by? If you're not sure, you can always take the second number and divide it by the number before it. Or take the last number and divide it by the number before that. Every time you do it, you'll get the same answer. 10 divided by 5, 2. 80 divided by 40, 2. Which means these are all multiplying by 2. And that is our common ratio. That is our b. So when you write your function will look like this. The x is your exponent. Now, what does that mean? Well, every time you plug in a number, you're plugging it in right here. So if you plug in 0, you're going to get 5. If you plug in a 1, you're going to get 10. If you plug in 2, you're going to get 20. Because what's 5 to the 1 power? How many 2's are you going to have? You have 1, 2. So that's going to be 5 times 2. But if you put the second power, how many 2's are you going to have? You're going to have 2 times 2. So that's 4. What if you plug in 3? That's 2 times 2 times 2. What if you plug in 4? That's 2 times 2 times 2 times 2. So this is what it represents. It's multiplying. This is going to keep multiplying by 2, and the exponent tells you how many times you're going to multiply it by 2. Now, if you graph this, okay, you would start at 5. 1, 2, 3, 4, 5. Right? The next one would be at 10. So you 6, 7, 8, 9, 10. The next one would be at 20, so somewhere up here, right? And what it does is it curves. It should curve going up, like that. All right, now, something you need to know. On the negative side, it curves down. It curves down, but there's a rule. It is never going to cross the x-axis. It's never going to cross that line. It's going to get closer and closer and closer to it, but it's not going to cross it. We call that an asymptote. Now, what the asymptote is, it's a line that the curve will never cross. Now, we give it a number. So if this is the line, it's at right here, that's the number 0. So what that means is the asymptote is at y equals 0. It will never cross 0, which means if it never crosses 0, it'll never go to the negative side. This function will never cross over to the negative side because the asymptote it acts like a boundary. It will not cross it. Okay. Let's do one more. Okay, again, my y-intercept is 54, and I need to find the pattern. Now, this is where it's harder. To find a pattern like this, wait, that's not getting bigger, but it is multiplying. So, ladies and gentlemen, you do the same thing. If you're not sure what it's multiplying by, you take the second number, divide it by the one before it. or go to the last number and divide it by the one before it. Okay, you're going to see that you're going to get a decimal here. But let's not write a decimal, let's write it as a fraction. What is 2 over 6? Well, if you simplify that, you get 1/3. If you simplify this, guess what you will also get? 1/3. Now, there is a calculator that will let you do it this way, so I'm going to show you that calculator later during the lesson, but you want to write it like this. So what this means is it's multiplying by 1/3. It's multiplying by a fraction. Okay? So when you write your function, right, when you write it, you're going to start with 54, but you're multiplying it by 1/3 to the x power. So I like to write my fractions in parentheses. You don't have to do that. You can just put a dot if you want to, like I did before. But that's another way to write it using parentheses. Now, if you graph this, let's just count by tens. 10, 20, 30, 40, 50, 60. 54 would be right here, right? That's 54. Next number is 18. So 10, 20. So 18 would be somewhere right here. Next number is 6, somewhere right here. The next number is 2. So what you notice is this curve is going down. And on this side, it would be curving upward. It would be going up, like that. So it acts very much like the other one, but kind of in reverse. So like this one started low and went up. This one started high and went low. Now, this has the same asymptote. The asymptote is still at 0. The curve will still not cross to the negative side. It will not cross to the negative side. So the asymptote is at y = 0. It will not cross this line. Okay, so those are really the two kinds of functions you're going to have. Those are the two kinds. Now, the simplest ones that you'll get, I know this kind of reverse. You would think I'd show you the hardest ones now. But I actually think the simplest ones are a little tricky because when you see a function like this, you're like, okay, that's my a, but it's not. Because this is the number that has the exponent attached, guys, this is your b. This is your common ratio. So what's the a? What's the number in front of b? So guys, if you get this, you have to remember there is still a number in front. The number is 1. The number is 1, okay? And the way you can actually test for this is if you make a table, okay? If you make a table for this, the first thing you're going to want to plug in is a 0, really. Now, if you plug in 0, you don't get 0. When you take 4 to the 0 power, when you do this, the answer is 1. You can do it in your calculator, and I'll show you. The answer is 1, okay? So anything to the 0 power is 1. The next one, if you plug in a 1 in here, if you plug in 4 to the 1, you get 4. Because how many 4s do you have? You have 1 4. 4 to the 2, you get 16, and so on, right? So you get a pattern like this. But at the beginning, you don't start at 4, you start at 1. So this kind of graph, 1, 2, 3, 4, that's not the starting point. But people do this because they think, oh, the 4 is the a. No, the starting point is at 1. The first number at 1, that's 4 right there. Then the next number is 16. Okay, so don't start your curve at 4, you start your curve at 1. So if you see something like this, your starting point is at 1. And again, you still have the asymptote. The asymptote is at 0. It's not going to cross 0 line. Now, something we should talk about. If you notice, none of these have been on the negative side. None of them. So your y values, the answers you're getting here, are all positive. So this we would call the range. Your range. So if you look at your range is your y values. and they will always be greater than 0 because the asymptote doesn't let the curve go below that. It can be above it, but it will never be below 0. So the range is always greater than 0. Okay, that's it.